Hello, everybody. My name is Mr. Huber, and today I've noticed that some students are having kind of a tough time with some matrices, and they're looking to do a retake. So today what I'm going to do is I'm going to go through each of the questions on your Chapter 3 Matrices intervention sheet. So we're going to look at all of those to hopefully answer any questions that you have and get you prepared for that retake. So let's go ahead and pull open that document now, and we can start taking a look at those problems. All right, so the first target 0 says I can solve a 2-variable system of equations by graphing, substitution, or elimination. All right, so I'm not going to show graphing today, but I will show the other two. So I'm going to start by using substitution. So in this one, it lends itself rather nicely to substitution because I already have this y variable isolated. So I know what y is equal to. Y is equal to this right here. So what I can go ahead and do is I can substitute this in for this y variable in our other equation. So I would have 2x plus 5. And now instead of that y, I write what I'm substituting in. So that would be that 2 minus 3x is equal to negative 3. All right, and now we just have to solve this equation for x. So I can go ahead and distribute this 5 to both terms. So I have 2x plus 10 minus 15x is equal to negative 3. All right, and now I'm going to combine my two x terms. So I have 10 minus 2x, and a negative 15x would give me a negative 13x is equal to negative 3. I'm going to subtract 10 on both sides so that I get negative 13x is equal to negative 13. And last but not least, let's just divide each side by negative 13. And I should get x is equal to a positive 1. All right, however, we're not done quite yet. We have to plug that x is equal to 1 into either one of these equations. I'm going to use this bottom equation right here. So y is equal to 2 minus 3 times x. Well, we just said x is 1. All right, so now I have y is equal to 2 minus 3 times 1 is just 3, or you could say plus negative 3, doesn't matter. So I get y is equal to a negative 1. All right, so on this one here, I got x is 1, y is negative 1. So that would be using our substitution method. In the next one, let's go ahead and look at using our elimination method. So basically what we're going to do for elimination, and I actually prefer elimination, we're going to multiply one of these two equations by some constant that is then going to cancel out either the x variable or the y variable. All right, so if I went ahead and I took these two equations and I added them together right away, I would get 5x, and this would be plus 2y is equal to 20. Notice we still have an x and we still have a y, so we can't solve for either of them because we have two variables. So I need one of those to cancel out. All right, so what I'm going to go ahead and do is I'm going to multiply this bottom equation by 3. All right, and here's why. 3 times 2x is going to give me 6x. 3 times negative, well, this is really a negative 1y, would give me a negative 3y is equal to 3 times negative 1. We have to distribute that 3 to all of these terms. 3 times negative 1 is a negative 3. Okay, now I'm just going to rewrite this first equation right here, that 3x plus 3y is equal to 21. And now when I add these two together, I'm going to get 9x. Oh, that's why I multiplied it by a positive 3, because now these two terms cancel each other out. So we do not have a y variable anymore, which is good because then we can solve for x. All right, and I have is equal to 21 minus 3. So that should give us what, 18? So then I'm just going to solve for x. I'll divide each side by 9, and we should get x is equal to 2. Okay, now it doesn't matter where you plug this x is equal to 2 into. I always tell students one of our original 2 equations. So I don't know, maybe I'll plug it into this equation here. So I'm going to take my 2, plug it in for x all the way up here. So I now have 3 times 2 plus 3 times y is equal to 21. All right, now I just have to solve for y. 3 times 2 is 6 plus 3y is equal to 21. Let's go ahead and subtract by 6 on each side. That cancels. I get 3y is equal to 21 minus 6 is what, 15? And then divide each side by 3. I get y is equal to 5. So for this one, I would have the point 25 as their solution. All right, and that is how we would use the elimination method. Okay, moving right along. Let's look at how we would graph. However, it's not your typical graph because we have inequalities here. So we're going to be graphing these two inequalities. Inequalities just means you have that greater than or less than or equal to sign. Okay, first of all, when we graph these, we need to know if it's or equal to, meaning it has this line underneath, okay, that is a solid line on your graph. And if it does not, this is a dotted line on your graph, okay, and we'll talk about that later, okay? Now, these are both very nice. They're in what's called slope-intercept form, so that y is equal to mx plus b that you learned last year. All right, so that m is our slope, and that b is our y-intercept. Okay, so remember, y-intercept is just if we have our coordinate grid here, this is our y-axis. And if we had a graph, maybe like this here, your y-intercept is where that graph crosses your y-axis. Okay, so let's just make a little note of that. So here, my y-intercept is -2. So I'm going to come over here. Here's my y-axis. I'll put that point at -2. My slope is 3/2. Remember, slope is always rise over run. So I have +3, so I'm going up 3, +2, I'm going right 2. Up 3, right 2. Up 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Okay, and now I can draw my line. And remember, we want this line to be dotted, all right? So that makes it a little trickier because then I can't hold it down at the end. That's okay though. So there's my dotted lined graph. All right, the last part is just to determine where we want to highlight. Do we highlight above the graph or below the graph? All right, so we have to come over here. See how y is greater? Pac-Man always eats the bigger number. So y is greater, therefore we shade above the graph. If y is greater, we shade above. All right, so I'm going to go ahead and shade this. Kind of like using the highlighter for this. Let's even make it a big highlighter. Okay, so I shaded above the graph there. Now when I graph my second one, and maybe I'll do this one in blue. Okay, I have a y-intercept of +4. 1, 2, 3, 4. And my slope, although we can't really see it, we know it's -1/1. So a negative slope, remember that's going to go up and to the left. So I want to go up 1, left 1. So up 1, left 1, up 1, left 1. Okay, so this is my graph of my second line, and notice this one is or equal to, so I actually want to fill this graph in. It should be a solid graph line. Now we just determined if we want to shade above or below. In this one, y is less than. Okay, so therefore we shade below our blue line. All right, so if I change my highlighter, let's do blue. I want to shade below. Okay, and now to find our solution, we find where those overlap. So see in the top here where it's just red, and the bottom here it's just blue. Well, red and blue together make purple. So let's go ahead and just highlight what they have together in purple. So that would be all of this right here. And then we can even erase our other ones. And there's our solutions. All right, so that kind of reviews some graphing, also with our inequalities, which is kind of what's new here. Moving right along, and this is now on to the tricky part. Now is when we start talking about matrices. Okay, so target one is you can add, subtract, multiply, and identify elements of equivalent matrices. Okay, so this one says if we have this matrix right here, plus this matrix, it equals this matrix. Addition and subtraction of matrices is very nice because it's exactly what you would think. The position of the numbers of the matrices line up. So for example, in this one, I'm solving for x. Notice x is in the top center. Whoops, let's make that a little bit smaller. Top center plus this matrices top center is equal to our solution matrices top center. They all line up, okay? They correspond. So in this one, I have 2x plus 8 is equal to 20. And now I just have to solve for x. So now it's just basic algebra. So I get 2x is equal to 12, and then I'll just divide each side by 2, and I get x is equal to 6. All right, however, in this one, we can now see that we're multiplying by a constant. So this 2 and this 3. Okay, now when you multiply just a matrix by a constant, what we actually do is we distribute that constant to all of the terms in that matrix. Okay, so I'm going to rewrite this matrix, distributing that multiplied by 2. So 2 times 4 is 8. 2 times -3 is -6. 2 times x is 2x. 2 times 5 is 10. Okay, now in this one, what I'm going to do is I'm going to distribute a -3 because I don't really like subtraction. So I'm just going to make this addition. And now let's distribute that -3 to all of these. So -3 times 2 is -6. -3 times -2 is a +6. -3 times 1 is -3. And this would then be a -3y is equal to our solution matrix, which is 2, 0, 11, 6. Okay, now we just have addition. So again, it's just whatever corresponds. So my 2x is in the bottom left-hand corner, plus this bottom left-hand corner is equal to this bottom left-hand corner. So let's go ahead and write that out, and then we can do our algebra step. So let's go ahead and do it in, I don't know, maybe green. 2x plus -3 is equal to 11. And now let's just solve for x. So I'm going to add 3 to both sides. 2x is equal to 14. Let's divide each side by 2. And I get x is equal to 7. Now let's do our y variable. Notice your y is in the bottom right. So I have bottom right plus bottom right is equal to bottom right. All right. So we have 10 plus -3y is equal to +6. Subtract 10 on both sides. So I get -3y is equal to -4. Divide by -3 on each side. Ooh, we got a fraction on this one. That's kind of ugly. It's all right. Sometimes we get fractions. So I would get y is equal to -4 over -3, but a negative divided by a negative is really a positive. So I'm just going to write this as +4/3. So I have x equals 7, y equals 4/3. All righty. So those first two, not that bad. Even number 3 is along the same lines. So I just want to, it tells me down here, we want to multiply that A matrix by -2. So I'm just going to go ahead and write -2 here, and then we're going to do the exact same thing we did in the last one, where we distribute that to the entire matrix. So I have -2, +6, -8, +4. So that is my new matrix A. And then it says minus matrix B. So I'm going to put minus, and I'm just going to copy down matrix B is 3, -1, -2, +1. Okay, now this one just wants us to actually do the subtraction. It did not give us a solution to the matrix. All right, so all I have to do is -2 minus 3. Okay, then this one here would be 6 minus -1. So this one in blue, this would be -8 minus -2. And last but not least, I don't know, maybe purple. 4 minus 1. So now let's just go ahead and do our math here. Okay, sometimes what I'll do is I'll change these all to be plus the opposite because I don't really like subtraction. So I'm going to change this to be plus the opposite, plus the opposite, plus the opposite, and plus the opposite. So now I have -2 plus -3 is -5. 6 plus 1 is 7. -8 plus 2 is -6. And 4 plus -1 is 3. And this would be our solution to that problem there. All right, we're moving right along. Okay, and at any point, you guys can kind of skip around if you already know an answer to one of the problems, just kind of skip that problem and move right on to the next one. Okay, now we're doing multiplication of matrices. Okay, you can multiply matrices by hand. And I'm not 100% sure that you guys kind of discussed how to multiply matrices, but we have to multiply them with this row and this column. Okay, and I really don't think you guys talk too much about it because what we can do is we can just multiply these on our calculator. So I'm going to use a couple different calculator apps today. And you can download both of these on the Hub app. So I'll go ahead and I'll show you that Hub app. So here's the Hub app. And this is like the App Store without logging into an Apple account. That you can download like paid apps that our district has paid for. So you don't have to buy them, which is even better. So if we go to all apps, I'll show you kind of the two apps that I'm using. The first is this matrix calculator. I kind of like this one. It works pretty well. So I would install that one. The other one is Calculate 84. Where's that one? There it is. Calculate 84 is the other one that I will be using today. I like this one because it's probably the most similar to your graphing calculator. However, it lacks a few features that we need for matrices. So I'll kind of start with the Calculate 84 just because that is the most similar to your graphing calculators that you'll be using later on. So you'll notice that this matrix button is right here above in blue. So I'm going to hit second matrix. All right. Now, this first section just names those matrices. We have to go over to the edit section to actually type in what that matrix is. So if we go back to our problem, not this. There we go. We have two 2x2 matrices. Okay, so I'm just gonna label the first one. So So I'm going to go edit. Let's make it 2 by 2. And then that matrix 4, -3, -2, 1. Okay, once you finish typing that matrix in, I always tell students to do second quit and then second matrix again. And now let's edit matrix B. Matrix B is also a 2 by 2 matrix, and it's 1, 2, -3, 5. 1, 2, -3, 5. All right. And then second quit. And now that we have those typed in, we want to name them so that we can multiply them. All right, so I'm going to go second matrix. Whoops. I'm going to name A, and I'm going to multiply it by second matrix. And now I'm just going to name B. And this is how easy matrix multiplication is when the calculator does it for you. All you have to do is hit enter, and boom, we get our matrix answer. So I got 13, -7, -5, 1. 13, -7, -5, 1. 13, -7, -5, 1. That's all there is to matrix multiplication if you're using your graphing calculator, which I highly recommend. All right, this next one sounds like a very challenging problem. It's actually not that hard. Okay, so this one says, let A be a 3 by 2 matrix and B is a 2 by 5 matrix. What are the dimensions of the following? If multiplication is not defined, write not defined. All right, so we have this first one is B times A. Well, B is a 2 by 5. Okay, and then A is a 3 by 2. Now, what do we have to look at to know if we can do this matrix multiplication? Well, you have to look at their middle two. Okay, so we have to look at these two right here. If they are not the same, you cannot multiply this. So notice one is a 5 and one is a 3. Therefore, we cannot do this. So I would just say not defined. Okay, but if we flip this around, and now we're doing A times B, well, A is a 3 by 2, and B is a 2 by 5. So let's see if we can actually do this. Ah, these are the same. Therefore, we can do it. But what does our answer look like? Well, your answer is these other ones. So it would be 3 by 5. That would be your solution matrix, would be a 3 by 5 matrix. So I'm just going to write 3 by 5 matrix. And that's all there is to number 5. All right, so we're whipping right along on this review. We've already finished up a couple of targets here. We're moving on to our next page. Okay. Target number 2, I can evaluate the determinant of a matrix. All right, so a lot of people, when I've been asking, what do these bars mean? I've gotten a lot of absolute values, which normally it does. However, if it's in a matrix and you get those, it actually means determinant. All right, so let's talk about how we find the determinant and why we use the determinant. All right, so to find the determinant, we're going to do some cross multiplication. So we're going to multiply these two numbers together. So that would be 1 times -2. and subtract it by these two numbers multiplied together. So that would be -1 times -5. So in this case here, we had 1 times -2 is -2 minus -1 times -5 is actually a +5. Okay, I don't like subtraction, so I'm just going to change it to addition of the opposite. And I should get my determinant to be -7. Okay, that's all there is to it. Or if we wanted kind of a formula to how we find the determinant of a 2x2 matrix, we could just name these with variables. All right, so it would be A times D minus B times C. So now let's look at this next one. It says let R equal this matrix here, and the determinant of R is 4. Okay, so all we would have to do is same thing. I'm just going to multiply these two together. So that would be 3 times -2x, and then subtract, and that would be these two multiplied together. So 5 times 4. So I get -6x minus 5 times 4 is 20, and it told us that the determinant is 4. Yeah, 4. So I just write equals 4. And now I can solve this for x. So I'm just going to add 20 to both sides. So I get -6x is equal to 24. And I will divide by -6 on both sides. So I get x is equal to -4. Okay, but now we're evaluating the determinant of a 3x3 matrix. Okay, now you could do this by hand, and it's very similar. All you have to do is we would have to do the diagonals again. But I go to do this diagonal and there's no number here. So what you would have to do if we were doing this by hand is copy down these first two columns again. So I'd have to go 2, 4, 1, -2, 5, 1, because now we have the 3 diagonals. However, it is a whole lot easier, and you guys are allowed to use your calculators to just do this on the calculator. So this is when I'm going to use the other matrix calculator. So I'm going to plug it into this matrix calculator, which for some reason only goes vertical. So my matrix that we're looking at is 2, -2, 6, 2, -2, whoops, not 5, 6, and then you have to use this little arrow to bring it down a row. 4, 5, 0, 4, 5, 0, down a row, 1, 1, -1. All right, now that we have it typed in the top left, you'll see DET. DET means determinant. So I'm going to go ahead and click that. And it gives me -24. Just does it right for you, nice and easy. So I'm going to pop back over. I'm going to say that this determinant would be negative 24. Easy enough, especially when we can use those graphing calculators. All right. Now, the reason that we need that determinant is so that we can find the inverse of a matrix. All right. So this one says find the inverse of the matrix. So first we need to find the determinant, which is what we were just doing in our last couple examples. All right. So we said we want to multiply these two. So that would be -4 times -2 minus, and then we want to multiply these two. So that would be 3 times 2. -4 times -2 is +8, minus 3 times 2 is 6. So I got 2 as my determinant. Now, to find your inverse, you have to multiply your matrix by 1 over your determinant. Okay, or in this case, our determinant is 2. So now, just like before, I have to distribute this 1/2 to everything in my matrix. Well, multiplying something by half is really the same as dividing it by 2. So I'm just going to think about these more as dividing it by 2. So -4 divided by 2 is -2. 3 divided by 2, I'm just going to leave that as 3 divided by 2. Just because, I mean, it would be 1/2, but I'll just leave it as a fraction. 2 divided by 2 is just 1, and -2 divided by 2 is -1. All right, and of course, we can check our answer on our calculator as well. So I'm just going to plug this into that app that we were just using. Sorry, it kind of flips my screen. All right, so we have -4, 3, -4, 3, 2, -2, 2, -2. Okay, now to do an inverse, you just have to click this A-1 button that's right next to determinant. So watch what happens. It does it right away when I click it. So I'm just going to click on A-1, and there's my inverse. -1, -3/2, -1, -2. Okay, I forgot one extra part that we have to do for our inverse. The last part that we have to do. We have to flip-flop these two numbers and then negate these two. Okay, it's kind of confusing, and we'll write a formula real quick for it. All right, but our final answer here to match our calculator would be -1, -3/2, -1, -2. And now you can see it matches that calculator. -1, -3/2. Yeah. All right, so if we were kind of writing a formula for this, and I'll change my screen back to the right way, maybe. Maybe not. Come on. Okay, so we want to do 1 over the determinant times, well, if we had the original A, B, C, D, well, now we would flip-flop A and D, right? So this would be D and this would be A. And then we have to negate B and C, minus B minus C. So that would be how we would find our inverse on that one. Come on. Let's reshare my screen. All right, so this video is already getting a little lengthy. I think we're already at like an hour on this video. But again, you can kind of skip around, use what you need. And I will make a second video that discusses kind of the last couple of pages. So I know that those are some of the harder ones. So I'll go ahead and make that video too. All right. So go find that video if you need help on those ones. Bye, guys.